Good afternoon.
Good afternoon. I'm Amir Beker, co-founder and CEO at IdentifAI Genetics.
My name is Noam Shomron. I'm a professor at the Faculty of Medicine at Tel Aviv University.
And IdentifAI Genetics chief scientist.
Thank you.
So please tell us how do you
A day job and a night job.
Exactly.
I'll talk about the science first. Our body is built out of billions of cells, and every cell has one long string in it, the size of about 1.8 meters long. That's the genetic makeup, the code of life, the DNA. Every cell has it. 3 billion nucleotides. But in fact, in our blood, we have tiny pieces of DNA at the size of about 150 nucleotides. They can come from various cells. During pregnancy, at week 10, the ratio is 9:1. 9 pieces of mother's DNA, 1 piece of embryonic DNA at week 10. And billions of these tiny pieces of DNA circulate in the mother's blood. During pregnancy, obviously, we want to make sure that the embryo develops well. So we have sonography, but also invasive measures in order to test or check the DNA, amniocentesis, and CVS. However, there is some risk for pregnancy if you run these invasive tests. About 10 years ago, other technologies have developed NIPT, non-invasive prenatal testing. That means you can take a simple blood test at week 10 and you can see embryonic DNA there. Now, these machines read the collective set of DNA, and if there's a tiny bit more of chromosome 21, that means the embryo suffers from trisomy 21. But if you think about it, it's actually looking like at planet Earth from outer space and asking, is there an additional continent? Because that's the resolution. Is there an extra chromosome? And what we wanted to do is to increase the resolution and see every nucleotide, every letter. Imagine in Google Earth, you can double click on a particular country and then street and then even house. So the resolution is much, much finer. And we were able to do that. So a former MD PhD student in the lab, Tom Rabinovich, who's now in the company as well, was able to find tiny differences between the embryonic DNA and the mother's DNA. This is a real graph here. The embryonic DNA size is in red. The mother's DNA is in black. It's slightly skewed. If you add additional features and more features, you will be able to completely separate it. And if you use AI and deep learning, you get a complete separation. About 3 years ago, we were able to identify a complete embryonic DNA from beginning to end, 3 billion nucleotides from a simple blood test taken at week 10 from the mother. We also did it at week 7, and we can probably do it even earlier to that. Look very carefully at these two images. Look very carefully, they're slightly different. If you see the difference between them, raise your hand. Okay, I see someone here. Anybody else? Another one over there. So there's 2 million pixels in these images, in each one. And I removed 1 pixel. In our DNA, we have 3 billion pixels. Anybody willing to give away 1 pixel from their DNA? No, okay, because we don't know where it will land. Now, if we were to ask a very simple question, is there an image here? 40 pixels are enough. That's enough to answer this question. However, if we really want to see the proper image, we need a finer resolution. So if you think about it, the image on the left-hand side is looking at the chromosome. The image on the right-hand side is looking at every letter in our DNA. Now, do we really need it? Yes, we do, because 1% of all pregnancies carry a mutation that can lead to a disease. And if I take the entire genetic test today, I will see only 10% of them. And we also know that sequencing costs are going down, genetic information is going up. We know that the average parent's age is increasing and there's less children per family. So we want to get it right the first time. When we work on AI, in genomics, we really feel like there's massive amount of information and we're trying to drink from a fire hydrant. Massive amount of information. We're really trying to reach better decisions and as early as possible.
I think I'll take it with this fire hydrant and take it from here. So thanks, Noam. I've met Noam, I think, 5.5 years ago at 8400, cohort 2, and became friends. And at first, Noam wanted to call this talk how to endanger and risk a wonderful friendship by setting a company and working together. Luckily, we did risk it, but we stayed good friends.
Still.
Yeah.
Not forever, you know.
No, not forever. After this talk, I'm not sure. And 2 years after Noam and Tom published their groundbreaking publication about the ability to actually have a whole genome sequencing out of a blood test from a mother, IdentifAI Genetics was founded at 2021 in order to bring this wonderful science and deep science to the clinic. It was conceived and incubated and born without any defects, I think, under the roof of Shizim, a life science holding company and a venture hub owned and headed by Yossi Bonshan, our chairman, here with us. And since then, we have taken it quite a long way in order to bring to the clinic an algorithmic process, starting with the wonderful science from Noam's lab and ending with a genetic report. So what you see here is a schematic depiction of the whole pipeline, where IdentifAI Genetics actually focuses on the computational part. We're a totally in silico company, and this is one of the great advantages. We do not interfere with the process of the doctor, of the pregnant mother. In the process of the lab, we are sending the plasma to the lab for sequencing of the cell-free DNA, the fragments, and we are doing the in silico fragmentomics and generating the sequenced fetal DNA after separation and after alignment. It's a huge problem, and the market is huge. Currently, NIPT, non-invasive prenatal testing, as it is today, can answer around 10% of the genetic anomalies, mainly chromosomal and subchromosomal, and we are about to expand it to 100%. So the whole spectrum, the whole gamut of genetic anomalies. First, we will concentrate on the inherited conditions where known carriers, the parents or at least the mother, are known carriers of a known disease, and then we will expand it to the whole market, actually treading on the paved road that the NIPT paved during the last decade. In the past 4 or 5 years, it's totally regulated, it's reimbursed, there is coverage, and the market is used to it. Only it doesn't give a complete answer and a complete picture. Another wonderful advantage is that validation in clinical studies is pretty easy. We have already completed clinical studies in medical centers here in Israel with dozens of cases, dozens of pregnancies in real life conditions. In the MFM OBGYN department of the hospitals. We've moved to the Columbia University Medical Center in New York and opened a clinical study there last December. This is the big good news of the company from last year, and hopefully we can publish and present the interim results during Q2 2024. Thank you. Hopefully the real clapping will be when we introduce good results. It's quite a rapid time to market. It's not FDA pathway, it's CLIA or lab developed test pathway, so we're going that way. However, we are preparing for an FDA regulatory path within 4 to 5 years, so we're already preparing our regulatory strategy to meet both CLIA and FDA. It's a very active market there. During the past decade, mergers, acquisitions, including acquisitions of specific technologies and specific algorithmic pipelines were abundant in this vibrant world. So you can see some of the big names that were involved in such mergers, acquisitions. This grants the company the opportunity either to go the whole way and be a standalone company, or generate more and more algorithmic pipelines and technologies and solutions and offer them to these giants. That's our company. We have raised more than $6.5 million, $2 million of it in grants from the Israel Innovation Authority, and the rest in equity investments, lead investor eHealth Ventures, or a VC fund. I think we are gender balanced, and we boys are striving to not to lag too far behind the ladies. Everyone is, as you see, smiling and looking expectantly at the results and successes, healthy successes, that the future will give birth to. Thank you very much.
Thanks so much, guys. Such an interesting solution, really quite powerful, and so interesting, such an interesting use of AI. So I'm going to fire you a quick question from our side, a two-part question. Number one is, I think it's incredible technology, and as I understand, you are screening women only really when they find a problem. How do we get people to screen before the problem arises so that we get early notification of things? So I'd like to know about that. And what is it you are looking for to get to the next stage? You're looking for partners, more hospitals to put the trials into? You're looking for investment? Tell us what you're looking for, please.
Thanks. So first, the first offering is for known carriers of the disease. Still, there is a chance, 25% chance that the fetus will have no disease, 25% that it will have from both parents, and then 50% from one. So right now, there is no other means to, other than invasive test to know whether the fetus did inherit or not. This is where we are right now. Next will be just a standard, de facto standard of screening for every pregnancy. So this is actually the NIPT state right now, but it covers only 10% of the cases. What we are looking for, that was the next question. So actually we are looking for partners, for big partners, since we do the computational part, and one of the huge labs or huge NIPT companies could serve as the front company to market it and also to do the wet parts that we're not interested in. Leveraging our capabilities, our unique proprietary technology would be staying in the computational domain. And that's what we are trying to do.